Completing the square. So this is something we will need in MA101 Geometry. So the idea is to look at a quadratic expression like I have on the right here, and note that that can be written as something squared as on the left, so that we no longer have a term like this one, linear in x, just a square. So if I'm given an expression like x squared plus 6x plus 1, I want to get rid of this term, which looks like 2ax above, and write this in the form x plus 3 all squared, so this is my value of a here, plus some constant. So what's the constant? Well, if I expand x plus 3 all squared, I get x squared plus 6x plus 9. That's too big. That's too big by 8, or 9 minus 1 if you prefer. So x squared plus 6x plus 1 is x plus 3 squared minus 9, and I'm adding on this 1 again. That's x plus 3 squared minus 8. Okay, done. Let's do it. Another example. X squared plus 5x plus 6. So again, the first step is to take the middle term, divide the coefficient by 2, add x and square. I'm going to expand that out to give me x squared plus 5x plus 25 over 4. So then I have that x squared plus 5x plus 6 is x plus 5 over 2 all squared. I take off the 25 over 4, so here's my completed square bit, and then I add on 6. So x plus 5 over 2 squared minus 25 over 4 plus 6. 6 is 24 over 4, so this is minus 1/4. And so in both those examples, the coefficient of x squared is 1. So let's look at another example where this first number is not 1. And so all I'm going to do is take out this common factor of 3 and write this as 3 times x squared plus 3x plus a third. Then I do exactly the same thing on the term in brackets. I take off the constant term squared, and then I add a third. Now I just have to do a little bit of algebra to tidy this up. A third minus 9 over 4 is minus 23 over 4. Sorry, over 12. And so this is 3x plus 3 over 2 squared minus 23 over 4. And we've got there using the same method. So why do we bother with this? Well, this helps us to solve quadratic equations. In fact, it's the way you derive the formula for the solution of a quadratic equation. So, the final example, how do we solve x squared plus 5x plus 6 equals 0? So now it's an equation, not just a quadratic expression. So we know from above that x squared plus 5x plus 6 is x plus 5 over 2 squared minus a quarter. And this we want to set to 0. So this should now be straightforward. It means I have x plus 5 over 2 squared equals 1/4. So if I take the square root of both sides, this is plus or minus the square root of 1 over 4, which is plus or minus 1/2. Then I take the 5 over 2 to the other side. Means that x is plus 1/2 minus 5 over 2, which is minus 2. And the other solution, x equals minus 1/2 minus 5 over 2, which is minus 3. And it is indeed the answer, because you notice that x plus 2, x plus 3 is exactly the quadratic we started with. Okay, so that's how you complete the square.